Hi, everybody. Today we're going to talk about data observability, a topic that is super interesting for data engineers because we have a lot of troubles usually with our pipelines. I have Ryan with me today from DataBand. He helped me with my video about data observability and about monitoring. So let's get him in. Hey, Ryan.
Hey, what's up, man? How you doing?
Hi, good. Thanks for being here.
Yeah, thanks for having me.
Yeah, so as I said today, data observability. We both talked. We are going to take questions throughout the stream, right? So for
If you
everybody
got
who's already
questions,
here,
go ahead and hit them over. I'll try to answer them the best I can. But if I can't answer them, I'll just make up an answer and make it seem like I know what I'm talking about. So,
yeah, Ryan, can you tell us a bit about you and maybe a bit about DataBand?
yeah, for sure.
Introduction.
Yeah. Thanks for having me on here. I'm always excited to talk to new audiences and tell them about what I'm passionate about, which is being a part of really innovative companies. So, for the past decade or so, I've been working in B2B SaaS startups, and so from test automation to DevOps to cybersecurity and now into data. I've been really just running go-to-market programs for these fun, exciting, industry disrupting companies in these spaces. And most recently was DataBand. So I ran all the go-to-market activities and marketing for DataBand that recently got acquired by IBM. So very exciting time for us to be acquired by one of the best, most innovative companies out there, especially in the data fabric space. And they've got obviously everyone knows who IBM is. So they got a lot of stuff going on over
Hmm. You said acquired by IBM. So do you know what was, or most likely what was the strategy behind IBM that they decided to purchase DataBand and go into that
there.
direction?
Yeah, for sure. Yeah. So there's a lot of news articles out there. Anyone can go read and learn about that. But essentially, if you look at kind of what the press was saying about this acquisition was that, IBM's been leading in the data space for a really long time. From Netezza to Watson X now, like they've had their hands in a lot of the AI stuff that's now really kind of up and ever since ChatGPT came out, everyone's freaking out about AI, but they've been on the forefront of AI for a really long time. And a part of that story involves, you got to have good foundations for building certain models and building machine learning algorithms, building all these things like data products and data analytics, et cetera, right? And the way you do that is through data fabric. And so one of the big strategy around acquiring DataBand was that they didn't have a solution in there that was around this proactive data quality, proactive data reliability that could be monitoring all of the data workflows and pipelines and things going on within the the data producers are doing within the data fabric to actually get to the end state where the data is consumed in a reliable manner. And so they kind of saw DataBand as, hey, this would be a great addition to Data Fabric to help us with this data reliability problem what our customers are talking to us about. And it really opened the door for us to have more conversations around customers that are using things in the modern data stack. I put this in air quotes because I think that term is thrown around a lot. But let's just say your data stack that's got a bunch of random stuff in there, right? From Databricks to Snowflake to Airflow, or in your example, using just simple Python jobs to run executions. All these things are things that we know our customers are actively using alongside IBM products. And what's great about observability is that DataBand is kind of that layer that's over all of these things that tells you when things break and how to go fix it, and ultimately help you deliver more reliable data. And so there's a data fabric component of why that made sense. There's also this broader observability discussion that's going on in the space, right? You have companies like Datadog and Instana and Turbonomic and Observe and New Relic and all these other different observability solutions that are out there. Data observability is a component of the broader observability trend that's going on from your CTO or CIO or CDO. That term observability is thrown around a lot, and it different tools do different things depending on what the end goals are trying to be. So if you're in DevOps and software engineering and software application, what you really are looking at is, hey, I want to make sure I'm monitoring something that's in production that's really on the application or microservices side. Okay, great. Well, there's tools for that. But if you're a data engineer and you're, ingesting tons of volume of data from third-party resources and then pushing that, and need to push that in a reliable way as fast as you can, you don't have no observability solution for the actual data pipelines that you're running. So that's where DataBand comes in to help those produce data faster but more reliable.
Can you explain a bit? Because Aziz here said, just starting out as an engineer. So you mentioned data fabric. Can you define this a bit? What you mean for the beginners with data fabric?
Yeah, so data fabric is basically a set of architectures and tools and solutions that make up your data-driven, posture. So, for example, when IBM talks about data fabric, there's different use cases within data fabric that you may need depending on which consumer you are. So, if you're a consumer of a data warehouse, data lake, data science, BI, you may need certain tools and solutions that would be a part of your holistic fabric approach. And so for IBM, we have things like Match 360 that gives you a view of all of your data. There's things like Data Stage that does a lot of the ETL transformation ingestion for low code, no code pipelines that you have. We have things like data replication. Watson Query does things like data virtualization. Then we have a massive solution around Cloud Pak for Data that's really around not just all these things kind of together, but also layers on top of it a knowledge catalog. So if you're thinking about data catalogs, data governance, data orchestration, all those things are different pieces to the pie that need to be a part of your data fabric that allow you different consumers to really tie into the different areas of your business that you want. And data observability is just another component of that data fabric. And so when we're talking to customers, a lot of times they don't just talk to us about one thing. Oh, I need data observability. It's, hey, we're struggling with our lakehouse transformations that we need to do. Hey, we're struggling with getting real-time analytics to our customers. Hey, we're struggling with our AI models not being correct. Like all these things require something beyond just observability. And so Fabric is a way to have that conversation that allows you to have just a bigger conversation about your holistic approach to data versus just this one solution or one tool that you
have. Okay. Because so you mentioned often like how it's not just like looking at individual pipelines, right? Because when I started and years ago, nobody talked about observability. It was, okay, I need something to monitor my pipelines.
Yeah.
So what is for you data observability, which is a super tongue twister? I always have problems with it.
I always mess up too. Like you'll hear me stumble all the time because I struggle with data producers. Like I don't know what it is. But I can't say words
sometimes. Okay, but what does that bring to, or how does that elevate just monitoring? Right? Because monitoring, you also mentioned a bit proactive monitoring is usually just, okay, if I don't need it, I don't look at it. And
right. Yeah, I mean, we have this conversation with customers every day, which is they have some level of like simple monitoring. So for example, they've set up some structure around maybe like an airflow monitorization that they have. But they don't have a full end-to-end monitoring approach that we've more of an observability across different pipelines, of pipelines connecting to one another that could tell them of, okay, there was really an error that happened around the ingestion of like let's say a broken API that got ingested into an Airflow DAG, that Airflow then kicked off a dbt process and then connected into a Snowflake table and then was consumed by a BI report. They don't have the observability across that entire lens. So if one thing breaks, they can't tell a story about why these other things may be impacted. And so I always there's a graph that I like to show. I won't show it because I know that people are listening on audio, but really I separate it into different categories. One is like a view category. So you may have a lot of times I'll say, yeah, we have a very limited view into our operations around our data pipelines. We hear that a lot. So going from a limited view from a more holistic view, as I talked about, being able to monitor how different pipelines are connected in an impact analysis or lineage view, very, very important. The other thing is like they can tell you like what happened, like, oh, this failed, but they can't tell you the what, where, and why it happened. So they
Mm.
can't tell you like, oh, this was the root cause of the issue. It relates to this person on this team that needs to go and go fix it. Doesn't show any trends related to the pipelines, how it's acted over time. So observability kind of gives you just like that kind of holistic view, and also more context around what's going on. The other thing is we talked about isolated systems. If you have monitoring on one tool, you may not have monitoring across all tools kind of coming together in one incident management solution. That's a problem. And then it's more of a reactive approach versus proactive. And so reactive approach says like, hey, uh, this failed, or we find a data quality issue maybe all the way in your warehouse table. Okay, well, if you had a more proactive approach, you probably could have caught that as it was in transit, maybe more upstream. And so we like to talk about how observability can be more of a proactive approach to data quality versus a reactive approach to data quality, and actually enhances more of your data quality tools that are out there today. So if I were to kind of encapsulate it, monitoring is, hey, a pipeline failed. Observability is like, hey, here's the pipeline that failed. Here's the root cause. Here's how it impacts XYZ dependency. And here's how to go fix it, right? Here's a suggested way to go fix it. So that's how I would kind of describe the difference between just pure monitoring and the observability that a lot of, again, not just DataBand, but a lot of other tools out there really promoting that full holistic view of like how to actually troubleshoot a problem and go fix it, prevent it.
So for beginners, what do you suggest for beginners? How should a beginner start? Because I'm guessing you can go super complicated very quickly.
Yeah.
This. So
yeah. So we have like and there's a lot of different ways to categorize observability. So I mean, and I will say this: like no tool right now does everything. And you can have observability across things like your data content. That's actually looking at the data completeness and uniqueness and accuracy. There's data pipeline flows and the jobs that we're kicking off. That's primarily what we're talking about today. But then there's other things like infrastructure compute power, like what's going on in your infrastructures or infrastructure set in the correct manner. Others is like how are users actually utilizing the solution and who owns what. And then the other one is more of like this FinOps category, which is how much are we spending on certain things like DBT tying into Snowflake, and is that making our Snowflake warehouse kind of go crazy? Do we have enough power on our data stage jobs to make sure that we're able to deliver the pipelines on time as we're consuming more and more data? So there's things like that are part of that holistic kind of approach to observability that no one today yet has that. Everyone's kind of marching towards that or partnering with other tools out there like data catalog solutions with observability to kind of have that more cohesive story. But I would say like if somebody's just getting out with data observability, we have a 5-step process that we walk through people around from critical all the way up to the top. And the first thing we always tell people is like when you want to set a observability around a certain pipeline, one is like identify the most critical pipelines you have, and then simply just set alerts around the states of those pipelines. Like that's it. That's like your first step. So I always use this analogy a lot, which is if you have a train and the train's going from New York to Georgia, I'm in Georgia, and you get on that train, well, the first thing you want to be able to know is the train moving or not? Is it moving or not? Okay, great. If it's moving, great. Okay, did the train slam on its brakes like right away as soon as we went 5 minutes down the road? Okay, that's a problem. Or is it stuck? Or is it going too slow? Right? Those are types of things at least get to a state where you can go, okay, is it running? Did it fail? Is it slower, or did it start and stop? Then you get into things like pipeline latency. So like how fast is that train moving? Is it moving at the speed that we know we're going to get to all the way to Georgia, right? One of our customers uses DataBand to monitor, airflow cluster jobs that they have. Where whatever managed service they have. And they noticed that the duration of those pipelines got longer and longer and longer as they were ingesting more and more data. And the only reason why they knew that is because DataBand was alerting them on, hey, you have a duration alert set to your pipeline, so you need to you need to be within this window. It goes outside that window, there's a problem. Then you can see in DataBand all the different data set, the amount of ingested data kept going up in that pipeline. Well, there was no more, there wasn't any additional resources to add to the Airflow cluster to actually make it to where it would meet within those parameters. So that's an example of like pipeline latency. Then you get into things like, hey, we want to monitor, the cargo on the train. That's the data itself, or were there changes on that cargo? That's a schema change. Like, was the things happening there? And then like, did it actually get to its final destination in the right time, right amount, and be able to be accessible by certain people? That would be like, hey, I finally got off the train in Georgia and I'm walking out to go to my destination. So we always say, like, start with the simple things. Like, start with the pipelines that you're running, and make sure you get the states and durations set up, especially if you have hundreds of thousands of different pipelines going on. Identify the criticalness of those. Add certain alerts to those that are either severe, medium, or low, so you're not getting all this noise in case like there is something wrong with the pipeline, but it's not super urgent. And then put up rules in place where you can immediately notify the people that are they're in charge of these pipelines to go fix them, and with the root cause analysis for that. So that's how I would say where to start out is probably there.
Yeah, because so runs, latency, schema changes. Like, how do Eka asked here, what do you think is the right time to implement data observability? Right? Does it depend on maturity? Which I guess.
Yeah, I think that the right time is when, again, I could do it by number of pipelines possibly, or how many data engineers you have, things like that. But really the problem gets to is if you start to have questions, or you start to have problems that are constantly being issues, and you can tell a story around those issues in ways that like sound like they make sense. That's when you need to really look at it. And what we have is, like, when we do our conversations with customers, I mean, we're constantly writing down things that they're telling us so that we can make sure that when we are talking to them, we're talking to them in the verbiage that they say. And so we've done this ever since I've been here, which is like, let's encapsulate this into actual quotes that we hear from customers, and read those back to them to make sure that another customer may be having the same problem. So for example, we talked to a cryptocurrency customer, and they said this, that we cannot afford to wait to know if a critical pipeline is down or the data set is not being delivered. That would be in breach of our data SLAs. So this particular person had a problem with their data SLAs constantly, and they're like, well, we got to fix this. Like, what's going on here? And I would say, like, not the problem, but the reality with data observability right now is because it's such a trigger innovation and it's not something that's mainstream, people are having a hard time describing the problems that they're facing, and they're trying to figure out solutions to them, not knowing that observability is probably the best solution. We had an investment advisory firm we talked to said that every day our source data has missing, inaccurate, or incomplete values. This degrades predictions and lowers quality for product to our customers. We can't have that. 3D design software company said that when we present customers with inaccurate information, the results are lack of trust. And then a customer that's a real estate customer said, hey, today we need to know if our customers, we need our customers to tell us if our data deliveries are late, and it's frustrating. So these are all things, if you're having these conversations with your team or manager or director, whoever it is, and those seem to be like those statements stick out to you in your head, that's probably a time you need to be looking at data observability.
These are the typical things, right? Missing data, wrong data.
Yep.
Not knowing what's going on with the pipelines. I know, like, These are the
Yeah, I
things
mean,
that you they
it's a
always.
problem that I think has gone on for a while, right? It's not something that I mean, when I talk to people that have been in data engineering for a long time, these same problems are problems that have been happening forever. It's not something that's new, right? And one of the things that I talk about this a lot, but I think that we don't give enough empathy towards data engineering teams and the struggles that they deal with on a day-to-day basis, like we do for other companies or other people in other positions. Because data engineering teams are the lifeblood of the data in your organization. They're the ones that are literally like moving the data and needing to check it fast to make sure everything's okay. Constantly being at times could be getting calls in the middle of the night saying, "Hey, what happened to this data? This is wrong. What's going on?" They're under pressure a lot, and there's always this term of like firefighting because they're the producers and they have to get it to the consumers. And it's very similar to the I think the thing I saw in test automation when I worked at this past company called Tricentis, which was you had this fight between the developers and the QA engineers and the stakeholders that were actually using the product. And at the end of the day, like the developers and just needed more help in making sure that their code was tested properly so that they were fixing problems more upstream than downstream. And that's what data observability is trying to do. It's really trying to help the producer side be more efficient so that you're not having to have these constant problems between the producers and consumers that at the end of the day a lot of it is like they're doing the best they can. They're just under pressure and under the time crunch to get this data to them in a way that's at times like
Mm.
almost unmanageable. It seems like.
And the thing is, though, I think that's because very often because the observability factor that you mentioned like having this proactively, having a lineage where, let's say, the engineer is not at work, but the problem, somebody sees the problem at the dashboard or something, that they can actually figure out, okay, where is the data coming from early, and then tell these people to fix it early, because very often these time crunches is just because nobody recognizes that there's an error, and then it takes time.
Right.
Okay, what's actually going wrong, and like then the stress comes in.
Yeah,
So
for sure. I mean, one of the use cases that we talk about a lot, which is there's the first one, which is, hey, I detected an incident, and here's how to go resolve it and fix it, or I was alerted that there's a problem that probably somebody would have found eventually, and we just found it before they was caught in production or whatever. The other one is like we're finding things that are there that probably would never be found in production had we not found it and alerted you on that particular thing. And one of the things that we talk to people about is uh, even though, let's say, your pipeline was green, that doesn't mean that the data and everything went through perfectly and everything was fine, right? Everyone knows this. Like being in software testing, right? There's multiple conversations I had with developers where they would say, "Well, my Jenkins pipeline ran; it was green. It's fine. There's like nothing wrong with it." It's like, well, wait a minute,
mm,
like. I know that you're telling me that everything looks green on your side just because there was no failures or tests that you did in your unit tests or integration tests. But hey, I found something. Like I know there's a problem. Like I'm not making this up. And so one of the things we like to highlight is just that outside of your pipeline, making sure that it's good and it's green, you got to make sure the data that's being delivered is also not full of irregularities or issues. And we use this as an example a lot, which is there's a way to look into different data sets, whether it's in Snowflake or being transformed into DBT models, things like that, where we can set parameters and anomaly alerts around things that may look to be accurate, but it went outside of a deviation. And so there's an example we give where we say, hey, we're always expecting the distinct count to be 5. in this particular columns, you can only select these 5 variables. We always assume these 5 variables. Anytime it goes outside of these 5 that we know were selected and it gives something that's an irregularity, we're going to flag it and say that, hey, there's a problem here. Now, the only way that people would know about that is if we had an alert set there, because if the green is going, if a pipeline ran, everything's green, you may think, oh, everything looks great. Everything passed. Like as data engineer, you're going, yeah, great. Got it there on time. It's done. But that doesn't mean that the actual data there is accurate. So we throw in data quality alerts and things like that to also enhance the pipeline reliability stuff that we do.
I think anomaly detection is actually super important, because also from my history of working on IoT projects, the problem very often was, okay, you were not able to actually set the alarms because you did not exactly know where should I set the alarm.
Yeah.
But if you have something like an anomaly detection where you say, okay, let's 10% plus minus is okay, or just roughly, then give me an alarm. That's very, very helpful.
Yeah.
That's also
Anomaly detection is great. I mean, we're not the only ones that do it. I think we do it really well, but I mean, there's other tools out there that do it as well. But I mean, one of the things great about anomaly detection too is it helps you set baselines that you may not know you set. So, I mean, if you can say, hey, I want to look back at what our past 50 pipeline behavior looked like, and then identify like what it should look like, what does right look like, then you can set certain sensitivities around like how sensitive you want to, alert outside of pipeline behavior. So it at least gives you an idea of, okay, these past 50, like that, the past 10 were the first 20 were okay, but the next 30 were like, that's not the way we want it to be. Let's change our look backs and then, or run it multiple times, figure out what the correct look back should be, then look back at the last 10 and make sure those are all really good. Then set your anomaly based off those last 10 because those are the best ones. And then anytime, if an 11 or 12 pipeline runs and it's way outside of that, within that sensitivity, then you can say, oh, this is a problem. So it's really getting to help you get to, I think, core team goals around like what is our pipeline behavior, what it should look like, and then we can alert on deviations after
that. I'm just thinking about, because that was also that's also in DataBand where you can go in and then configure this. I'm also thinking, okay, what else was interesting that I saw that I really liked? I really liked the that you always saw the schema, and that it basically also counted automatically. Okay, that's the amount of columns you always have, and then you can look it up and immediately see, oh, something's going wrong, right?
Yeah, no, the schema alerting is awesome. Like that would be, when we get to customers and we start setting up their environment, that'd be like a level like 3 or 4 when it comes to the types of things they want to look at. But the schema alert stuff is great. I mean, I think that one of the things that that is also great about the schema alerting is that it will give you, just like the trends around the pipelines, we'll give you the trends around how those data sets were interacting as well. And so I think a lot of times people think about pipeline observability, it's like, oh, is that all you're doing is looking at pipelines? Like, no, like we're collecting a bunch of metadata from all of your processes going on. And so the types of reporting you can do within DataBand and the types of reporting you can do to stakeholders and to just see like how we actually operating here is really important. The other thing is the aspect around DataBand has incident alerting within an incident management centralization. And so versus just kind of alerting, hey, let's go resolve it and move back. We keep all of the logs of all of the alerts that you've done. So you can track to see like, okay, we've had DataBand for a year. How many alerts has DataBand set off? We expect that to go down because we're hoping, we're resolving issues and then we're fixing our processes that we're suggesting possibly to fix, so that DataBand becomes a, hey, we found all these things, great. We really made our process way more efficient now. That's awesome. Now we're using it as to detect anything that may fall outside of those processes that we worked really hard to fix. And so, the goal of DataBand isn't to increase your alerting, right? It's to
Mm.
set the alerts that you want within the observability framework that we set out, and then get those alerts down, because we want to make sure that you're fixing process, optimizing your processes as you're detecting these issues, and not just detecting them, fixing them, and then, oh, by the way, here comes the same alert that we had, 5 hours ago. Like, you don't want to do that.
Yeah, that's true. But from an engineer side, I mean, that's why engineering is quite a safe job, because you're never going to get to zero. It's always going to be
Right.
something.
Never a zero bug data product or software product.
That's absolutely true. Yeah. I mentioned schema changes also because I was it's been, I don't know, 2 years. A student of mine, he was saying they have in their pipeline very often problems. They are using external APIs, especially from Apple.
Yeah.
And what these people do sometimes, they just change the API without any prior notification. They
Yeah. Yeah.
just do changes, and then on the other side, the engineers or people then later wonder, okay, what's going on now? Where's the problem? And without actually knowing that the schema changed, you are going to go step by step through everything and take a long time to actually figure out, okay, the problem is exactly here in the early stage, and it's the incoming data. It's not something that we did wrong, but it's the data that's coming in. So
Yeah.
I find that very
Yeah, there's and I'll have to get your thoughts on this too, but there's a movement now in the space around data contracts. Have you heard about this? Have you heard about seeing some stuff
a
on
bit.
that?
I don't know his name. There's one guy on LinkedIn that
It's
constantly posts about.
Chad Sanderson.
Yeah,
Yeah.
exactly.
Shout out to Chad. He's got a new company out there called I think it's called Gable. But yeah, he's trying to. I think what they're trying to do is solve that problem, which I don't really know how it works with third party,
Mm.
uh, that multiple supplier angle within your data. I'd have to look more into it, but I think he's looking to kind of build like a GitHub for data and
Mhm.
make sure there's like these API contracts between the producers and consumers everyone can go back to, and make sure these things like are fixed more upstream. It's an interesting idea. Like, I know it's been out there, but I don't know if you had any thoughts on
For me, that's the second or the third stage. Usually, the problem comes in earlier, where there's not a good documentation, and the actual responsibilities. So the people and their
that.
responsibilities are not well defined for this.
Yeah.
And I think you can immediately solve a lot of problems if you really say, okay, that's the person or the group that is responsible. Here's the documentation of the API, and this is what everybody expects, right? And so I think that's that from my view. I haven't looked that much into data contracts, but I think that's it sounds like more of a third step to take in that journey.
Yeah.
But
Yeah, I haven't.
yeah,
Yeah, I don't want to speak too much on it because I don't know a ton on it. But I know it's been making some buzz in the data space.
yeah, because
Yeah,
it's such a big problem that people just
yeah,
change something, and they don't know how. Often it's not even on purpose that they don't tell people, because they don't know who to tell, right?
yeah,
You don't know exactly who's using the pipelines or the APIs, and then you run into these problems. So yeah, there's, especially for larger companies, there's a lot of work there.
yeah, for sure. I mean, there's always a discussion, which is getting back to the software delivery side and how the data sides. I see so many similarities between the rush to develop faster and produce higher software quality and push it out to production, CI/CD, all that stuff, right? But the challenges were very much the same in data. Like, everyone was starting to talk about, well, you got to shift more left. You got to shift your development practices and quality practices more left to catch things before they become issues like down the road. I think the same thing is going on like in data now. Like there's the idea of data contracts, data observability, data testing. All these things are coming into play to make sure that you're shifting more left upstream so that there isn't this, unknown problems that are in the data products when you're actually releasing them or in a dashboard or reporting to your CFO, like looking at data. And we're catching them a lot earlier. But again, it's easier said than done. And that's why I think there's multiple ways to go about and approach it. And you got to have multiple layers of safeguards in each of these and not just one thing.
Yeah, but like when I looked at DataBand, so my goal that I had for that video was actually, let's try to make this the simplest thing. Let's try to observe the simplest thing, because people always assume that these large tools, you need to have big pipelines and needs to be super complicated. And I really liked how easy this is to integrate into just a simple ETL Python script, right? And monitor this. And I think that's where observability is really, and tools like DataBand are really coming in, because it's no longer a huge deal to actually observe pipelines and have a good ops of your data pipeline.
Yeah. No, I mean, thanks for saying that. No, I mean, not that this is an infomercial for DataBand, but I like it. But no, I mean, well, like we say a lot, like the time to value with using something like DataBand for observability is like very quick, because like you're saying, you can expand it to be, all the way to step 5. And we talk about that on our website of what you want to do, but you can get immediate value, like what you just said, just tying into your existing pipelines to get that alerting right away. I mean, we had a customer that they had around 60% of the time that they had pipelines that they were running, they had an issue with that. After implementing DataBand, after about basically 3 to 4 months, they'd cut that down to like less than 1%. And the main problem that they were dealing with was that they just had too many pipelines to keep track of. So if you had something in there that at least was the ability to monitor your most critical pipelines, maybe not everything, at least monitor those most problematic pipelines, give you information on what's really going on, then you have the ability to fix that stuff. So the time to value is actually very, very quick. And I always tell people that, like, you don't have to start off and deploy this monolithic thing. It's a very simple cloud-based, go on-prem as well, ties into your existing tech stack very easily, and get going. Like we have integrations, like, you did the video on a Python pipeline, but we have integrations with Snowflake for data quality alerts. We have integrations with Spark notebooks and things like that. Airflow is the most prominent integration that we have. BigQuery is another one, and then anything that's again, I talked about Spark, so Databricks, WatsonX.data is another example of tying into that. So really, we can tie into all that stuff, and DBT Core, other examples as well of getting observability across those things. So, I mean, you can start with either of those. You don't have to have all of those things together. A lot of times people start off with just simply monitoring their Spark processes and Spark executions. That's a great way to start, because Spark's everywhere, just like Airflow, like it's everywhere. Yeah. So tie it in and then look for your next thing to expand your observability landscape to.
Yeah, this ties into a question that I get a lot. Very often I get it around AI, that if AI is actually making data engineering irrelevant, or you don't need engineers because of AI. The other one would be that tools like you've just explained are basically taking away from the engineering job, right? Because a few years ago, you had to do a lot of work to actually try to and let's just talk about monitor your pipelines, right? But I think and that's why I like these solutions, as you said, cloud-based, and it's easy to integrate, because this takes away the boring stuff for the engineer, the stuff that the engineer actually doesn't want to do. I don't want to set up maybe I want to set up some custom metrics or something, but I don't want to set up how to monitor the schema. I don't want to set up how to monitor the duration of my pipeline, right?
Yep.
And this way, the engineer can actually focus on the engineering, actually focus on the pipelines and maybe solving problems or building new ones. So
Yep.
for me, that's why I'm a bit of a fanboy of these cloud-based solutions.
Yeah. Well, I think I mean there was a report by Fivetran that came out maybe a year ago, I think. But obviously they're wanting to showcase how use Fivetran versus using a bunch of open source pipelines, things like that. But one of the things that they reported on was that I think it was either 40 or 50%. So it's close to, let's say, roughly half. They did a report, and data engineering said that roughly half the time that they spend is on fixing and maintaining pipelines. So that's a lot of time. Like, do you really want to be doing that? Like, no. Like, let's figure out ways to fix these and get them going. Like with something like DataBand, and like what you said, focus on stuff that is either building more products, more pipelines for products, doing things you actually like to do. Like, I mean, software testing too, right? I mean, software engineering teams, and I know software engineering teams aren't the same as data engineering teams, but there's a lot of similarities. I mean, software engineering developers, they hated fixing bugs. They didn't like to they want to build.
Yeah.
They want to build stuff. They want to see their software become actually something that's being used. They don't want to fix bugs. And so, similar thing, right? I mean, data engineers don't want to keep maintaining pipelines over and over and over again and fixing them. So, if there's ways out there that can help you alert on these things that are broken and need fixing and help you produce better pipelines, and why not use it? And so that's kind of what I'm talking about there.
Yeah, I think often the point is also thinking about software engineers. They don't want to fix bugs because they have so much work, because the work
Yeah.
package is already done and the next 10 are already
Yeah.
waiting, right? And so also as an engineer, you're always behind. There's always more work that you can actually do, and then when you have to struggle with these kind of things where you have to fix bugs, where you have to react react immediately to some problem that came up a day ago but nobody noticed it, that's
Yep.
where the big problem starts. Let me quickly look at my cheat sheet. Yeah, so we talked about the roles. I'm always very focused from the engineering perspective, but there are also from other perspectives, right? Let's say from the engineer and from the scientists or the analyst side. Can you say something about this with like problems that they usually face?
Yeah, I mean the science and analytics side is going to be more on the either the quality side or the delivery side, right? So whereas engineering is more focused on the processes and the quality within that. I mean, I'll give you an example. Like I was at Gartner Data and AI Symposium or something like that, and I was talking to somebody came up to our booth and we were talking about, hey, this is what we do. We're talking about IBM Data Fabric, and one of the questions they had was they literally said this, and people, I'm in marketing. People like can accuse me of making stuff up. I promise I'm not making this up, but because it sounds too good to be true. But they were from a major insurance company. They're on the analytics side, and they literally said, hey, do you have something that can help the data engineering teams catch things that aren't delivered instead of us having to Slack them in the middle of the night to alert them that we never got the data or whatever? And I was like, well, let me tell you about DataBand. But it was just very interesting because the analytics team, and I go, are you guys like, tell me how your team's structured? Are they here? Can I talk to them here? Like, oh, they're part of this other team. We don't really talk to them. Like, oh, okay. So you guys like don't really talk. Number one, you're not on this like small team, right? It's working all together. You're in separate silos, probably, which is very much common in enterprises. And this is a large enterprise. And so our question, they were basically coming to us with a problem that they couldn't fix, but they needed a solution to help the team upstream fix, so they didn't have to then go talk to them about fixing it. Which is a constant thing that we hear, which is, hey, the analytics and science team, analyst team, they're the ones that are complaining about the data that's not right or broken or not delivered on time. And a lot of times we have no idea that we're even doing anything wrong. So that's an example of just like the consumer and producer struggle that I think happens a lot. And it was voiced by somebody on the consumer side versus the producer side. Also on the producers or the consumer side, we do have data quality checks and DBT alerting that is more, I would say, further down away from traditional pure producers. If you're an analytics engineer or a data analyst that's looking at the data in Snowflake, things like that, we have alerting that's around that. So it gives a lot of value to them. They can look to see how that DBT model may have been produced by some other Airflow job or whatever. So it puts it in context of kind of what's going on. And then for both of them, the whole point is like to give you this lineage view that just shows here's how the data flew or is transpiring. Here are all the different connectors that are in place that cross paths with, so you guys can have a conversation together about it. So our lineage capabilities is really helping them solve what was the impact analysis and how did it affect different teams downstream and upstream, and then work together to figure out how can we prevent this from happening in the future. So I think there's a lot of value, not just for the producer side. I've been talking a lot about data engineering, but I do think that I talk about data engineering a lot because that's where if you fix that stuff, that's where you see a lot of the quick win value. Like fix that stuff first and then move on to the more right side of the equation when it comes to the data consumers.
You talked a bit about silos, right? Mm-hmm. And you see this all the time. Would you say, or how do you think a good observability solution changes that? Should that be changed, having silos, or what's your opinion?
I mean, I think that silos are going to be something that are just commonplace. Like as you get bigger and bigger in your organization, like that's not really going to change. But I do think that, based off of the different flavors of observability that are coming out, I think it does break down silos. So, I mean, like, again, getting back to things like data content and data flow and data pipeline. Okay, that's great for let's say like the consumer and producer side. But then when you get into things like financial allocation, okay, that helps break down barriers between like the conversation you're having with your CFO or your person who's actually in charge of giving you money to run the P&L of like a product of yours, right? So that helps with that and figuring out where there's some financial cost savings that could occur. Infrastructure and compute size, that gets all the way back to the data infrastructure team, data platform team, and not just the data engineering team. And understanding like, do we have enough resources to actually make our product make sure our product is actually going to be something that's sustainable as we add more and more load to the system, right? So I think that the observability component can help break down the silos in conversation. I don't know, it'd be great if everyone went to the two pizza model, right? That was famous by Amazon back in the day. I think that's what it's called, right? Two pizzas. Teams should be no bigger than people that can consume two pizzas.
Yeah, I think
something like that. Remember that?
Something like that. Yeah.
That was during the whole like DevOps like craze that was going on. But no, I think that you just have to, if silos aren't going to be totally not destroyed, but like harmonized together, and we work in worlds that aren't, we're not co-located right next to each other, obviously. And Zoom only helps so far. I think you've got to have tools that help have that discussion that's broader than just the data consumers and producers. Now it's getting into finance, infrastructure, and so on. So I think that observability will help for sure. It's going to get bigger and bigger and better and better. We're not just talking about pure pipeline observability at this point.
Yeah, I can see that because all these points that you're bringing up, that's way more than just observing individual pipelines, right? It's basically end to end, also with finance and leadership. So yeah. Um, we mentioned DataBand is a cloud service. Do you actually have something that let's say you have a large enterprise and they don't want to share or connect to the cloud their secret data? Is
Mhm.
there something that they can do with DataBand?
Yeah, we offer on-premise solution as well. So I mean, it
Oh,
can be
okay.
deployed on-premise through Docker containers, and I think we have it on a Kubernetes. You can deploy through Kubernetes as well. I think we may have a Red Hat installation, but yeah, the installation part on-premise isn't a problem. If
Mhm.
you go to IBM.com, look at the docs page, you can see kind of the different ways to do it. But yeah, we give that flexibility because obviously we know that not everyone is full cloud, and a lot of them are hybrid, and certain things are allowed to go cloud, and certain things are, hey, you got to go private cloud behind our own firewall. And so no, we have both solutions. I think there's very few observability tools out there today that are pure cloud, and the
Mhm.
reason why is because you got to have a story for the enterprise and major enterprises. And we know major enterprises aren't fully on the cloud. So depending on what they say and for security restrictions and data privacy laws, things like that, you've got
Yeah.
to have a solution that's on-prem. And being a part of IBM, we have the most versatile consulting and deployment options for you. I'll just say
Yeah,
that.
that's true. That's true. That's a big plus if you're within such an organization, also such a high recognized organization like IBM, right?
Yep.
It's not like any startup. But I think yeah, this is a problem. I'm how I got to this question because I struggled a lot with GDPR in my time, and
Yep.
all the documentation. Where is the data going? Who is responsible? Where is it actually allowed to go from a privacy standpoint, and so on.
Right.
And some companies, you also mentioned financial and so on. Maybe or most likely they are with certain things they're
Yep.
very restrictive, not from
Yeah, everyone
themselves, but
wants to
also for the
everyone
law.
wants to have financial services be one of their customers until they find out what all the restrictions are that you have to abide by as a vendor.
Yeah, that's that
It's
can
like,
be.
oh, gonna be a lot of work.
Let's have healthcare, financial, and something like that. Yeah, because that's problematic. Insurance.
Yep, all those.
Yeah. Okay, Ryan. Yeah. Where should people go? I have in the description a link to the products page.
Yeah.
Is that where people should go? Should they look at something else as
Well,
well?
they can always just. I mean, we have so much content out there. I mean, we've done stuff with you, George Farrakhan, Kate Strosny, uh, Eric Eckerson Group. We have a lot of content that is available just if you type in DataBand something, and you'll come up with videos, white papers, whatever. So I mean, if you don't know how to use Google, I can't help you. But just type in DataBand and things will pop up. But directly, if you want to go, reach out for a demo, have a discussion with us, see if we're a good fit. If not, not a big deal. But just you can go to IBM.com or type in IBM DataBand. You'll be brought to the product page. So
Okay.
also on databand.ai, there's a lot of videos of me and Eric Jones, one of our solution architects, and a lot of other specialists over here at Databand that are walking through the product, showing you how to use it, some of the core features, capabilities of it. So it can get you an idea of what the power is. And obviously, Andreas, you've got a video yourself on
That's true.
your YouTube
Yeah.
channel as well. So you can, if I get
Exactly.
annoying, if my voice is annoying, then just go listen to yours. So, it'll be better probably.
Yeah. And also, I would recommend what I really like that you have a lot of also blog posts out on there.
Yeah.
Like posts about super interesting topics where not everybody has time to watch a video, where you can just go in and learn about observability and learn about databand and I really like these. So yeah, that's my tip also. Good. Ryan, thanks for being here.
Yeah, thanks for
I hope
having me.
everybody had a good time. And yeah, see you next time.
All right. See you guys.
Bye.